Uranus has been hiding something from us for 40 years. When Voyager 2 flew past in January 1986, it gave us a quick snapshot of the planet. Rings, moons, a weird magnetic field, and then kept going. That was our one and only close-up visit. 40 years, one flyby, and a mountain of unanswered questions. But now, the James Webb Space Telescope has just pulled off something Voyager never could. For the first time in history, astronomers have mapped the upper atmosphere of Uranus in 3 dimensions, and what they found is rewriting what we thought we knew about ice giant planets. Here's what happened. On January 19, 2025, Webb locked its NIRSpec instrument onto Uranus and stared at it for 15 straight hours, nearly one full rotation of the planet. That's almost an entire Uranian day captured in a single observing session. The team, led by astronomer Paola Tirani at Northumbria University in the United Kingdom, was looking at the ionosphere. That's the electrically charged upper layer of the atmosphere, stretching thousands of kilometers above the cloud tops, where auroras flicker and the planet's magnetic field clashes with the solar wind. And what they found was strange. First, the temperatures. As you move upward through the ionosphere, temperatures peak between 3,000 and 4,000 kilometers above the clouds. That's the hottest band in the upper atmosphere. But here's the thing. The average temperature they measured was about 426 kelvins, roughly 150 degrees Celsius. That sounds warm until you realize it's significantly cooler than what ground-based telescopes and Voyager 2 recorded decades ago. Uranus' upper atmosphere has been steadily cooling since the early 1990s, and Webb just confirmed that trend is still going. Second, the charged particles. Ion densities peaked closer to 1,000 kilometers above the clouds, but they were notably weaker than what existing models predicted. The theoretical frameworks we've been using to understand this planet's atmosphere, they were overestimating how many ions are actually up there. And then there's the magnetic field, and this is where Uranus gets truly bizarre. Most planets have magnetic fields that roughly line up with their rotation. Earth's is only tilted about 11.5 degrees. Uranus? Its magnetic axis is tilted nearly 59 degrees away from the spin axis, and it's not even centered on the planet. It's offset by about a third of the planet's radius toward one pole. So the magnetic field is lopsided, off-center, and wildly tilted on a planet that already spins on its side at nearly 98 degrees. That crooked magnetic field creates some wild effects. Webb detected 2 bright auroral bands glowing near the magnetic poles. But between them, the team found a mysterious dark zone, an area where both emission and ion density drop off sharply. The magnetic field appears to be carving out a region where charged particles simply can't accumulate. Similar structures exist on Jupiter, but finding them at Uranus tells us something fundamental about how magnetic geometry shapes an atmosphere at the frozen edges of our solar system. As Tirani put it, the auroras on Uranus sweep across the surface in complex patterns because of that tilted, offset magnetosphere. Webb has now revealed how deep those effects actually reach. So why does all of this matter beyond Uranus? Because ice giants may be the most common type of large planet in our galaxy. When we look at exoplanets orbiting distant stars, we keep finding worlds roughly the size of Uranus and Neptune. Understanding how their atmospheres work, how they balance energy, how their magnetic fields interact with space, starts right here with the 2 ice giants in our own backyard. This study, published in Geophysical Research Letters, is a critical stepping stone. And with a potential NASA flagship mission to Uranus under discussion, Webb is already laying the groundwork. If you learned something new about the strangest planet in our solar system, hit that like button and subscribe so you don't miss the next big discovery from Webb. Drop a comment and tell me, what do you think is causing that mysterious dark zone? I'll see you in the next one.